This is Millikan's oil drop experiment. This experiment is one of the most important ever performed. Thomson had identified the electron as a charged particle in 1897 and had measured its charge to mass ratio. The next step was to obtain a value for either the mass or the charge. In Millikan's experiment, he sprayed oil drops into a chamber. In this version, we are going to use tiny latex balls that are sprayed into the chamber here. In this chamber are two metal discs at the top and at the bottom. We can observe the motion of the latex balls using a webcam here, and the space inside the chamber is illuminated with this lamp here. We can observe the motion of the latex balls on this screen here, which has a grid which enables us to measure the velocity by timing the motion of the balls across the grid. Each latex ball may have one or more electrons on it, and the more electrons they have on it, the more charged they are, and the more they will react to the electrostatic field generated here by the applied voltage. And it is by observing their motion that we can make the necessary calculations. Here's a view of all the equipment, various angles. So here you can see quite clearly the power supply with its high tension and low tension supplies. The first thing we need to do is measure the distance between the two plates. You can do that by clicking on the chamber like this, and it'll be dismantled, and you'll see the top plate and its separation ring and the bottom plate. The screw gauge can be used to accurately determine how wide this is. You can use the plus and minus key to zoom in, and this can be used to tighten up till it stops moving. There you can hear it clicking, and at that point you can read the gauge and get a very good reading for this distance here, which is what separates the two metal plates. When you finish measuring it, pull out and click on the chamber again, and the gauge will go back to its position and the chamber will reassemble. To start the experiment, switch on the power supply. This turns the light on here, and you can see an image on the PC screen of inside the chamber. Put the polarity to positive and increase the voltage up to about 300. You can see the voltage going up here on the meter. So go up to about 300. Then introduce the polymer balls into the chamber by clicking on the squeezy part here, and at this point you will see all the particles. Position yourself well. You were told in the documentation how far apart these divisions in the reticle are, and what you need to do is time these. Pick around about 40 or 50 different ones and time them, and these will be your means of calculating the velocity. You're also going to need some information on the balls themselves. If you zoom in on the bottle here, the latex particles, you can read off the size of them and the mass. So that'll give you enough information to perform the necessary calculations, and hopefully you will be able to derive the charge on a single electron. It's worth noting that many of these particles, especially the ones that move the fastest, will have multiple electrons on them, and this clearly causes them to move faster within the electric field, and the ones that move the slowest will have the fewest electrons on them. So that is basically how you perform this experiment using the simulator. Thank you.